welcome everyone. That was about the only AI content you will see this morning in this room. So welcome to Devox. Yeah, let's get started.
Yeah.
So, what are we talking about today? Well, guess what? I hope you know the rooms you're in, right? Build tools. So, let's start with a few questions. Who uses Gradle here already? Okay, so that makes sense.
Most everybody.
Maven? Yeah, and a couple duplicates. So I get these folks are the one using both. Yep.
Yeah.
Who does not use a build tool for their software development? Oh, 0 is actually a good number. Congrats. Who's happy about using a build tool? Still a couple hands.
Yeah, that's exciting crowd.
I'll let you go for these.
Yeah. So how often do you have to touch the files related to the build tool, updating dependencies, build logic? Do you do it almost every day? A couple hands, so a lot of interaction. Maybe just every once a week. Yeah. Half of the people. Yeah, and more luckier in the crowd who just touches it like just once a month. Yeah, there are people. Yeah, either you have a perfect build or you're afraid to touch it. All right.
So yeah, so today we want to go over a few things related, of course, to the upcoming Gradle 9 version. So we'll talk about the core evolutions. Why do we have such a release strategy in Gradle, and what do we plan for 9? And then we'll dive into 2 different sections: build comprehensibility, which is one of the focuses we have, and the other one, scalability. And you see that we have a number of sub-bullet points in there. We'll get into those during the presentation. And then at the end, we have a few future peaks, ongoing work, things that are not tied to Gradle 9, but could be exciting for Gradle users. But before we go there, let's spend a few slides on what is Gradle and what's the company that allows us to be here today. So it started in 2008, so that's already 16 years ago. And the goal is to improve developer productivity. That's one of the old, motto, build happiness. Of course, it starts with a Gradle Build Tool, which is open source. It's currently the default if you start an application on Spring Initializer, and we are above 45 million downloads a month. This is an amazing vanity number. It's actually caused by ephemeral CI. Please stop downloading the Gradle distribution for every single build. It's worth having it in your baked image. I know it will make the numbers go low, but still, it's better for you and for the planet. But behind the build tool, we actually have a for-pay solution, Develocity, which is effectively a solution that has acceleration techniques, those build scans that we'll talk about in a minute, and works not only for Gradle, but also Maven and SBT and Bazel today, and we'll have in 2025 support for NPM and Python.
So, and the developer productivity engineering is the discipline that Gradle pioneered and helps to improve the industry with a product related to that. And this is, well, as you guessed it, about making your developers really productive. And it's a relatively fresh discipline, also a fresh field of research. If you want to dive into that, there's great videos on YouTube called Showdown, where we explore specific topics related to productivity in different companies, and usually people from those companies like Netflix, Microsoft, or LinkedIn share their experience, how they exactly organize and improve their developer lives.
And so last but not least, so that's what a build scan looks like. That's one of the recent versions. So not only do you see everything that was executed, why it was executed, we've now added information about the amount of resources that your build is actually consuming, whether it's memory, CPU, disk access. Check it out. We have a free service, scans.gradle.com, that you can upload builds from the different supported tools. We're 4 minutes in. That was over for the non-open source stuff. Let's dive into the evolutions. Just before we get started, we have plenty of time, and so please feel free to ask questions. We have a couple caps for those asking questions. Can I get a cap is not a valid question. So that's settled. And we'll have stickers also on the table, so feel free to come pick them at the break.
Right. And before we dive in, maybe let's do a quick introduction.
Sure.
Yeah, so my name is Alex Semin. I'm part of the Build Tool engineering team. I'm working on configuration cache related stuff. I've been with Gradle for about 2 years and enjoying it a lot.
Yeah. And so I'm Louis, same Build Tool engineering team as well. I've been there for more than 6 years now, and I've done all different kind of stuff. And for the moment, I'm not too much into product development, but more managing releases, looking at the community, partners, things like that. Okay?
Yeah. So if you have any questions, do not hesitate to ask them at any time. Right. So we're talking about Gradle 9 today, but there is a perspective behind, obviously, and that means releases predating that, and for that means it's a 8 timeline. And with recent years, we really accelerated the pace of releases to make sure users are able to get the features earlier rather than later and give us feedback again. And with 8 line, we've been doing around 6 releases every year, I think. Yeah. And those are minor releases, which by no means underlies that those are minor releases by the content. All are packed with features, bug fixes, and come with extensive release notes, as well as upgrade guides, what have you. So every minor release is worth upgrading to, and since those are minor, they are fully backward compatible, so you are encouraged to do so, and the upgrade should be relatively quick. And as we go to Gradle 9, we expect to see a couple of minor releases down the road. So that would be the upcoming 8.11, which should happen in the next few weeks probably, and 2 or more minors before that. And after that, we go to work on the major release, and major means, well, multiple things. So first of all, it means major changes that we allow ourselves to do to the build tool. But the major upgrade does not necessarily mean major improvements in performance or whatnot, because they come in every minor release. So watch out for those first. But the major release allows us to break some minor or larger incompatibilities in the build tool, allowing us to unlock more daring changes to provide you more benefits going forward.
Yeah. So what comes with 9 then? Well, the first thing we're going to do is we're actually finally going to raise the minimal Java version that the Gradle daemon can run on. So you know that nowadays you can run Gradle with Java 8. For 9.0, we actually want to raise that minimum to 17. So I'm interested, who would have a problem with that here? A couple hands. So remember, Gradle for a while has had tool chains, and so you can still run things on lower versions. I'll take your question in a second. So we will still allow you to use Java 8 for compilation, testing, executing the code, for workers in general. So that stays in. OK. That answered the question, so I'm happy I waited. Yeah, so literally, the daemon will need 17, but you have the ability to actually use a lower version back to 8 for your production code effectively.
Yeah. Based on the majority of the statistics we saw, the majority of the industry already migrated, and there are only a few builds out there that ever try to run on lower versions, so that should not really be a problem.
Yeah. And if you have an issue, I think if it's a big problem for you, we have open issues on the issue tracker on GitHub on Gradle. Please do comment, explain your use cases. But we definitely want to raise that minimal version. I mean, Java 8 has been here for ages, and it's time also for our own enjoyment to be able to start using some of the more advanced features of Java.
For sure. There are also updates coming to the DSL side of things in Gradle. That means Kotlin DSL, which we are happy to be the proponents of, and that means we're going to upgrade the Kotlin language version from 9.1, that is currently today, to 2.0. That would allow you to leverage any of the Kotlin features that unlocks, potentially also the new Kotlin compiler, and which is a K2 compiler. The K2 shared by JetBrains means that it normally brings acceleration to your projects, but beware though that Gradle has a slightly different use case than your regular production project for the Kotlin compiler, because instead of compiling a large Kotlin code base in like a single compiler sweep, we compile individual scripts for different projects, so you might not see the speed up there immediately. Although if you author your build logic or like shared build logic or plugins in Kotlin, then you can see the speed up for sure.
So on the Groovy side, Gradle 8 skipped the Groovy 4 upgrade, so we really want to do that for Gradle 9. We know it comes with a couple of challenges because there have been changes to the Groovy language that might impact build scripts effectively. And so that's something we're trying to prepare. You should see a couple of deprecations coming out in the upcoming versions, not 8.11, but like 8.12 and after, to help you prepare. One example is get foo, if foo is a boolean, is no longer recognized as a property by Groovy 4. You have to use isFoo. And so that's something that will be in the way of some situations. Not all of them, but some.
Right. And the major version, as I mentioned, is also the chance for us to catch up with minor things. So normally we don't try to update third-party dependencies for the Gradle distribution itself, because updating every dependency could bring breaking changes to our users. So we try to batch those updates together with a major, so that if you have to deal with any outfall, you can do it in a contained fashion, and that happens only during majors. And that means updating the plugins we use ourselves, or the tools such as the third-party tools for verification of your code, checkstyle, PMD, CodeNarc, whatnot. Also things like things we bundle with other core plugins, such as the Scala plugin, and that means the sync compiler for that.
And then, of course, a bunch of fixes. Many bug fixes, because it's not because we're doing a major that we don't stop improving, that we stop improving Gradle. One thing that happens, though, is sometimes we collect these nasty bug fixes that are somewhat of a behavior change. And unfortunately, with the number of users of Gradle, we find that pretty much every time we change behavior, even if it looks like a bug and it is a bug and it feels like a bug, you'll still have a user complaining that they were relying on that behavior. And so the most egregious one, we actually delay them to majors. And then we clearly indicate that, we're fixing that, but it may impact your build logic if you were relying on that specific behavior.
Right. You would be surprised. The Gradle API surface is so large. It's so easy to find like a nitpick, a person who was keeping the, the space bar pressed to make their room heat up. Right.
Yeah, that classical XKCD.
Yeah. And for the major upgrade, something like a question we get a lot, or the feedback, is that sometimes people feel it's a bit hard for them to upgrade because there are breaking changes and they're not sure how to address that. And we wanted to give a quick guideline on what should be the smooth path in our opinion. So first of all, always upgrade to the latest version of your current major release, because anything that will change in Gradle 9 will be deprecated first, and that would happen sometime down the line of 8. So by upgrading to the latest, first of all, it should not be that hard because there should be no breaking changes, but also you will see everything you would need to address once you do upgrade. So do not rush to immediately jump from 8.7 to 9.0 when it comes out. Do the spaced upgrades, you'll do yourself a favor. And when you do get out there to fix those deprecations, we provide, on top of release notes, we provide extensive upgrade guides for every minor release and following up to the next major of the things to watch out for. So there is a detailed information there. If you can follow the link in the slides later, or just Google upgrade guide. You're going to find what you're looking for. And last but not least, there are some features that we're working on, especially major ones like configuration cache, that do bring some changes to the behavior, some new requirements. And in order for those to be satisfied, you do have to change your build logic, so we cannot enable it by default before the major version. And at some point in the future, we're going to enable configuration cache by default. And in order to smooth out that path, you can always opt in early in order to prepare your build to ensure the smooth upgrade. And once that's done, when you upgrade to 9.0, ideally you wouldn't have to do anything. So the major upgrade would be the least of your concerns. You would just see the benefits.
I guess one last call to action before we jump into the themes. Alex was saying that we have a pretty large API surface in Gradle. One of the things that we have also is that we have tons of internal packages that still show up in autocompletion for historical reasons. We're trying to find a solution for that. But please, please don't use them. Because we today have to consider part of what we expect to be our internal API to actually be public API, because it's used by way too many people. Which is an indication sometimes that we miss public APIs, don't get me wrong. But it's also something that's harder to manage. And so that's a collaboration effectively with the users. So we discussed some of the improvements that are coming with 9 that are more, like I would say, tactical, but we have a few strategical themes that we've been working on in the whole series of minor releases in 8, and that we want to kind of deliver as a meaningful set of improvements in 9. And so these themes are the build comprehensibility, so making Gradle easier to consume, easier to interact with for both the build engineers, so the folks that have to work on that build logic, and also for the software developers, the people that don't necessarily want to learn Gradle in and out, but still have to do things like upgrade a dependency, add a project, configure the memory for the test execution because the previous execution failed, and things like that. And so that's one big topic. And the second one is scalability. And so scalability has to do with anything that helps us make Gradle faster, more scalable, so that if your project grows, your build time don't grow with that growth. And I mean, effectively things we're gonna talk about more in details later in the presentation. Okay.
Yeah, and so without further ado, let's dive into the first topic of comprehensibility. What do we mean by that exactly? So that starts with the complexity. And who here thinks that they have a complicated build or a non-trivial one? About half the people. So that means that the challenge is definitely there. And in terms of addressing that challenge, that is a large one, we see it as our part, as the part of our overall technical Gradle vision, which is for Gradle to be the build system that is able to build software of any type, size, or complexity in a fast and reliable manner. But for the comprehensibility, we should focus on only a subpart of that, which is this complexity and the reliability part, where that means that you can reliably change your build logic, and when you are faced with problems, you're able to solve them quickly and understand how you did that, and not do that accidentally. And that brings us to people making mistakes. And when people make mistakes, for the build system, it's a requirement to show them errors, to not let them ship broken code to production. So the errors and warnings are part of our software development lives that we have to deal with, but they are not necessarily the best way to approach the information shown to the user. And so instead of just errors and warnings, we'd like to see the information the build tool displays as helpful messages that whenever you're faced with an issue or a problem, you can find your path around it in order to solve it. So, and yeah, the builds fail every day. That's okay, whether you run tests, compilation errors, or upgrade dependencies and things don't match. And this is something we should expect always. But in order for you to move forward, you should be able to diagnose the problem, so see exactly the root cause, because that's not always trivial, and then proceed to fixing the problem. And to that, we have a number of smaller and larger improvements around the 8x timeline. One of those is that simple thing that when you run a test and you see a different output, you definitely want to know, what is exactly that you got wrong. And sometimes, sometimes you see that in the IDE, you can see a special window to show you the difference between the outputs, but sometimes it's not there and it's unclear why exactly. So it turns out it has to do with the integration between Gradle and IntelliJ. And in 8.x, we actually fixed a minor issue that made sure that whenever exceptions are thrown that are related to assertions, we always unwrap them, and making sure that even if the setup for exception handling in plugins you use or whatnot is non-trivial or nested slightly, you can still get that nice UX of seeing the difference between the values. So in this case, you'll be always seeing the expected and actual, and you'll be able to see a detailed diff on that. So by just improving the Gradle side of things, we made it easier for almost all the users out there without having to wait for upgrades in IntelliJ IDEA. Right. Another topic of, things being complex, if you work with Gradle long enough, you probably saw one of those errors. So those errors are related to dependency management, and specifically a variant-aware dependency resolution, which is a very flexible feature of Gradle, covering many use cases, but as much as it is powerful, it could be hard to deal with when you're actually faced with problems. Yeah, so here's a typical example of a problem like that. And it doesn't stop here, so I have to really scroll to see the whole error. And any problem you face would be at least of that size. And so along the, I think 8.7, 8.6, we introduced some baseline in order to allow us to recognize some of the cases, some of the common cases that users face with those errors in order to make them more comprehensible and easier to handle. One of the... Yep.
I was part of the team working on that, so this was not the best user experience, let's be honest. The underlying system is amazing, but like you have to understand almost its implementation to fully make sense of that. So yeah, definitely having clearer help messages around that is a great improvement.
Yes. So the build system is always should target showing you the full information so you can have access to it, but it's a matter of potentially steps to uncover everything. And sometimes, in many cases, all you need is one tiny hint and you don't really need to dive in. And recognizing some of those cases is one of the important part of making the user experience better. And one of the examples of that is if you do add a dependency to your project that was compiled against a different Java version, instead of seeing that huge screen of errors, now Gradle tells you clearly that you should either change your dependency or upgrade your build in order to support that Java version. So, but if you still do want to dive in for whatever reason deeper, you can still use the dependency insights tasks, dependency management drill down tasks to verify, to get the full picture if you want it, or use a build scan. But for the majority of the users, seeing the plain message about upgrading Java is enough. Right. Another case that is slightly less common, but maybe for those of you build authors out there or plugin authors, is a similar thing when you make sure that Gradle is, your Gradle plugin is targeting a specific or a minimal Gradle version, which is possible to do by specifying a property when you publish your plugin. Then when you do apply the plugin, or unsuspecting users apply their plugin to their build without having the valid Gradle version, would have also seen a really undecipherable error, and now it's as simple as understanding that, hey, you're using an older version of Gradle, please upgrade that plugin, moved on. Last but not least is the example of recognizing the cases where the solution is just one step away and the constraint system of variance is actually able to figure out exactly what do you need to do in order to solve that, or at least show you the most prominent solution to that. And one example of that is when you have multiple sets of attributes, but you lack at least or exactly one of those to make sure there is no ambiguity, so you can resolve the ambiguity. And now Gradle can tell you that despite having those 15 other attributes there's just that one that is missing, and if you specify exactly what you need, then you get the right version. So that would be either the Java doc or sources or something else for the dependency that you add. Right. And yeah, so making errors better, that's definitely something useful for the users, but we don't always deal with the errors that come from the Gradle itself. Sometimes it's the third-party things or the more fundamental things we're working with, such as a compiler. And for the longest time, the way the compiler integration worked is that when you run the compilation task, whatever it outputs will be part of the task output where it naturally belongs. But since seeing compilation errors is such a trivial case in the software development lifecycle, it sometimes make it much harder to find that error, especially if you have a larger build, as somebody shared, that they have complex builds. Finding that output may not be trivial, and the UI that some IDs provide might not be ideal for it. So in Gradle 8.11, we are using the new problems API in order to integrate better with the compiler and not just work with its output in a raw form, but extract it structurally and be able to actually place it where you most likely to look, which is for the compilation error, the end of your output. So no longer, regardless of your build size, do you have to scroll. It's always going to be there in the end, and you'll be able to quickly go and fix the problem. And yeah.
So the audience is saying thank you, because they can't hear you on the recording, so sharing why we love. Yeah,
appreciation is accepted.
It's definitely long time overdue. I mean, this example is simple, but effectively, if you use Gradle in continue mode, meaning you could have compilation errors in more than one project, they will be grouped together. We will show the warnings as well if there is an error. If there are no errors, then we do not show the warning. Of course, you can always activate, -w error so that all warnings become errors, and then they're back at the end of the build. So that's really, in terms of usability, a nice improvement.
Yeah, and we plan to go one step further with that. We're working with some of your favorite IDE vendors to allow them to make use of that structural output and then present it in the UI instead of parsing whatever Gradle output provides. It would be actually detailed information on any problems, starting with compilation and later coming with deprecations and whatnot. So that would be a much better experience going forward. Right. And so the build output is actually a pretty integral part of working with any project. Whenever you run, whether you run your tests, whether you distribute your application, the output is what you look at, especially on CI, you don't really have anything else. So making it better structured and making the errors, or rather help messages, actionable is critical, as well as providing you with detailed documentation on where you can find more details. One other concrete example of what's been improved, but that's just one among many, is sometimes historically, the information that was displayed was just, there so that it's shown. But in this example, the last line is just a very long single line that combines everything, like what's wrong with the build, where the information was found, and where to go look for. That maybe could be really jarring to figure out, what part, why is my arrows showing to like that line word. But with the relatively simple, improvements, we could restructure the output and make it much more intelligible. So in this case, we see that the arrows to the left are actually just part of the merge conflict that are part of the line, and whatever you need to do is prefixed with the actionable item of verifying the log file content. Just look in there. Probably the problem is just something got inside that shouldn't be there, and then only then, if you do need more information, which in this case probably you wouldn't, you still can find the documentation, but that it doesn't obscure the main thing you should be addressing when you fix the problem. But introducing those tactical changes is only one of the ways to improve user experience. We're also working on something more fundamental to make sure that the comprehensibility of your build scales to whatever plugins you use, regardless of your build size. And one of the examples of that is the provider API and the way it helps you to solve larger challenges in the builds.
Yep. So yeah, let's look at what we mean by laziness in here. So what are the challenges? Well, Gradle uses build scripts that are code. And that means that you have something fundamental in code, which is evaluation ordering. Most languages will go in order. I mean, you can have optimizations lower down, but they will go in order of what you expressed, or at least they will evaluate according to a model that matches what you expressed. And so in Gradle, what happens often is that you're not sure, if you write a plugin, when the user will set the value. Like, they have the liberty of placing the block, which are mostly references to methods, extensions, things like that. And sometimes you're a bit at a loss in terms of, okay, when can I do something? And one of the constructs that Gradle provides for that is a project.AfterEvaluate, which effectively lets you register a callback that's called once the project has been configured. But if you call AfterEvaluate in your plugin and another plugin does it as well, who's last? And then you may have two plugins that you don't know in which order they will be applied, but you would like to do something after both have been applied. Like, where do you put that kind of logic? How after do you need to be? And so in short, that does not really scale. One of the classical examples in Gradle has been with the publishing plugin. So here you see a publications. We have another task that's custom. That task is about computing some form of artifact ID. Like, it could be any reason in your internal logic that you need some form of dynamicity there. But because currently the publication API does not use lazy evaluation, you end up having to do things like get me the task, which is a task provider, flat map its artifact ID, and then I need to read the value right now because I need to set it as a string to that artifact ID on the left-hand side. And so that's definitely one challenge. Another one is about execution ordering. The Gradle model for a task is that work produces files, because that's what you interact with mostly in the context of a build system. And you definitely have tasks that consume these files. I mean, a very concrete example in the Java plugin ecosystem is you compile things, and then you jar them in order to have a binary. And so the thing is, when you start building your own logic, or when you start wanting to influence the current logic of those plugins by adding more steps, more processing, like you want to obfuscate the Java code, you want to generate some code, you want to do those things, you need to create this relationship between the tasks. And one of the methods we offer for the moment is depends on. But depends on means you have to declare those dependencies. And if you miss one, sometimes it will work, especially if you already have local state. Sometimes it won't work. Like it's the classical, but it works on my machine, and then it doesn't work elsewhere. And you're looking for that kind of problems and trying to investigate and solve them. So as a reminder, the way Gradle works when it does execution is actually going through a task graph. And so you've got an abstract version of it, but a more concrete version on the right-hand side. Let's say you request build. When you request build and you've got JVM plugins applied, build will do two things. It will assemble all the binaries of your project, and it will run all checks. Those checks include test. The assemble means we need the jar. In order to get the jar, we need the classes, which are the compiled code. That means also processing resources, if you have properties file, things like that. And the way Gradle builds that graph is by effectively asking the build task, hey, what are your dependencies? And then moving forward through the graph, and then finally running with the execution. Well, it happens that a solution for those problems is actually laziness. What do you mean by laziness? Well, Gradle has introduced quite a while ago something that we call the provider API, provider properties. And the idea here is that you no longer deal with direct values, you deal with wrapped values on which we differ the resolution. It also allows us to keep information like provenance, where that value was set, or where does it come from, including a longer chain. But also tie that value to, oh, in order to produce that value, some work needs to be executed, meaning that anyone that tries to read that value will have to make sure that that work gets executed. And reading the value is something that you declare in your build script. Figuring out that it means running a task before is exactly what Gradle does in its engine. And it has also benefits, right? It can improve build performance. And we'll see why in a minute. So the goal of the provider API is that the ordering part in evaluation is dropped. You actually wire and derive values. You don't care when it's set. And the evaluation is done on demand. So if the task does not run, we don't need to compute its inputs. And that's where there is a performance benefit. Let's say that in your release build, you have to include some heavy information computed from the git changelog, which you do by running a set of commands, like even having some custom parsing for generating release notes, things like that, which a number of plugins do out there. Well, if you compute all those information lazily as a task input somewhere, then as long as that task does not need to run, none of those operations need to happen. And so potentially development builds, for example, are not affected by that. Then on the execution ordering, well, here we want to keep the ordering. Like the goal is to have that strong ordering. And so when you have a task output property that you use inside another task, the benefit you get transparently is that Gradle will be able to track those task dependencies. And our goal is that depends on, you should never use it. The only places where you would use that is for lifecycle tasks such as build, assemble, check, because effectively those are coordinating work. They're not really consuming outputs. They're more like saying, in order to build, I need to do both assemble and check. In order to do assemble, I need to go to all the produced binaries. And so there you need to express which are those. But that's the idea. In terms of API, you're looking at something that's definitely inspired by the evolutions toward more functional languages. And so what you do is you take those values, you can filter them, you can map them, you can get an alternate output if they're not set. You can combine them together, and all of those will keep track, again, of who provided that value, and if it's a task, then it means there is a dependency on that task. Of course, you have ways to extract those values, but these should be considered a code smell. You should have a very good reason for doing that. My example earlier on of the publishing APIs lacking this provider API support will be a cause, for example, for doing that get. So there are places where, unfortunately, Gradle is not yet fully using the provider API, and we'll get to why in a moment.
One thing to be said about that is you do have to unwrap your properties when you implement your task action. So this is the only place where you expected to call the gets and unwrap the values. Yeah. But in your configuration logic, it should never happen. And when that happens, it is a code smell.
Yeah, of course. Yeah, reading the value at execution time is definitely a use case. The whole provider API comes with support in the DSLs. I mean, Groovy got it transparently due to its dynamic aspect, but the Gradle team actually contributed a compiler plugin to the Kotlin compiler that allows us to define types that effectively can understand the equality as an assignment. Because the way you define these things, as you can see above, is through a val. So meaning you cannot write it. And so by definition, you should not be able to do equal something. Well, here in that sense, the equal something is a nicer way of writing that you're actually setting the value in that box container. Okay, so let's see in practice what this means. So I'm at an age where I need to move with the glasses now. And let me start. I will go here. Okay, so that should be visible, yes. So this is a build-init generated application which has a number of things. If you're familiar with Gradle, you'll find the settings. You'll find, because I turned on the options for having all the recommended features, we have a build logic build, which is an included build, in which we define a number of convention plugins. So these are defined by having precompiled script plugins. So these are plugins that I can write as if I was writing a build script. And we have a common convention that sets repositories, the way testing should work, which Java version should be used for compiling and running tests and all of that. And then you can see that I combine them with other plugins so that I have an application convention, a library convention. I mean, if you want to play around with like modern Gradle, building it is actually really nice because it will generate you projects that should use the latest recommendations from the team. So what I decided to do in there, though, was to actually do a code-based plugin. So I have real classes. It's written in Kotlin. So I've got my example plugin. And what it does simply is it's a project-applied plugin. And it does register two tasks, a consumer and a producer. And what I do is I have a convention value for the output file of my producer. So these are basic Gradle constructs. We can go look at the implementation of both the consumers and the producer. So here again, I leverage Gradle system. Gradle will instantiate your task, so it does not have to be an instantiable type. It can be, we actually wrap them, whether they're abstract or not. So the recommendation is actually to go with abstract, to implement, extend default task. The moment you use this manage type from Gradle, again, they can be abstract. Gradle will provide and inject the right things. And then, as you can see, my consume task action is not very smart. It's mostly about explaining that I'm consuming that file. And the producer is pretty much the same, except that this time I've got an output file. My produce code is really limited about writing hello world in that file. So that's pretty much what I have. So now, if I go and start by executing my code, And what I want to do is consume. What I get is an initialized build, so it takes a while to do it the first time, and I get a build failed. And the reason I get a build failed, and again, that's one of the examples of having, better error messages, is what went wrong? Well, there's a problem in my app consumer. Oh, that's the one thing I forgot to show. The way I work with that is I literally apply, let me minimize that. I literally apply my consumer producer example plugin here. That's pretty much it. So that's why these tasks show up in the application project. And so it's telling me that the property input file on my plugin Java Commons convention, oh, that's interesting. So it's probably applied twice then. Let's check that. Huh, that's a bug. That's an attribution error. It should actually come from my example plugin and not Java conventions. But it's complaining that the input file doesn't have a configured value. And if you remember, when I showed you the plugin, the only thing it was doing, it was setting a convention on my producer, but it was not saying anything about the consumer. So that means effectively the consumer code here doesn't know what to consume. On the other side, if I run produce, that will work, no problem. I've got a successful build, and if I go look into, sorry. Oh, interesting. I got my output here. Hello world. I've been playing around on that project, so output shouldn't be there. And build should be my build output, but I guess my IntelliJ was not up to date. So I've produced my file. That's what was done. Let me delete it so it's not in the way. And then what I can do is I can go here, and now what I can do is actually indicate that I want my consumer. And so when I do that, what I get is a task provider. So it's again a boxed value around the task. So it does not force the configuration of the creation of the task. It just indicates that if that task is ever required, please apply the configuration that I'm going to do here. And so what I want to do is I want my input file to actually be my tasks.producer. No, not register. What did he do? So that's actually wrong. Thank you, Copilot, but that's not what I want. I want the output of my producer. So if you remember, what I need to do is I need to flat map it and take its output file. So here again, I'm working in that functional environment, and I'm delaying everything. I'm just telling Gradle, oh, by the way, when you'll have to read that input file, I want you to know that it comes from the producer task. And then I'm accessing its output file. And that gives me a box type, again, which is lazily evaluated at runtime by Gradle, but it actually wires the two properties together. And so now, if I go back here and actually run my consumer again, this time I do have a successful build. And not only do I have a successful build, but if we looked at the build output, we can see that my hello world has been generated. So it means just calling consume had an effect on produce. One way to show that would be, for example, to just say that I'm going to print a line here. I would not recommend to do that in a real build, right? We have logging infrastructure and all of that. I'm just being lazy here. Please don't print line. If I rerun consume, of course, this time I've changed my build logic, so my build needs to recompile all of that. But one of the benefits is that since my producer produced output, it shows up in the invoke task. I can see that it's been invoked, and I can see that I'm consuming the value. And that's because I've got that wiring. Now, let's say that this happens somewhere, and somewhere else, someone on the producer goes ahead and changes the output to be, Devox Belgium. And again, back to a mode where evaluation would happen in order, you could say, oh, wait, I've wired the output file before I change its location, so this may not work. Well, again, let's delete build output, and then rerun the same consume. We'll see once again the producer was invoked, and what we're consuming is devoxB. And so this means that, and it's actually the only file that was produced, right? So once again here, what we see is that effect of we're delaying the evaluation of all this information. And so even though I'm saying first that the consumer should consume the output file of the producer, when this happens, all of that build logic has already been executed, all these callbacks and all these configurations are ready to be run. And I'm guaranteed by the execution model of Gradle that I will have the latest from the producer, because I will need the producer to run first, and only then will I look at its output file. And one more thing that we can do is we can actually change the build directory. Yeah. And so for that,
so not only working on the task level, but actually changing properties that are project related, sort of, on which everything else depends.
So here, this time, what I'm doing at the end is I'm setting a new build directory, which by default is your project/build. And I decide to use output. I guess you understand now why I had output laying around from before. And so once again, simply executing consume will show that my producer was invoked and that we're looking at output devoxb.txt. So this, of course, is a contrived example to try to explain the principle of how this works. But the whole point is that when all of that logic is spread around different plugins, different build files, you have that ability of stopping to reason about, oh, am I at the right time? Like, did the other configuration happen? No, it's really, all of that will be resolved as late as possible in the Gradle lifecycle, and with a way that allows you to combine those values to reuse them without having any problem. Any questions on that? Yes? So the question is the wiring between the tasks still done at the configuration phase? Yes. So what happens is that this generated wrapper knows that it actually carries a task dependency. And so at the configuration phase, Gradle will not try to resolve the value, but it will get the provenance information, the task dependency information, and then decide, oh, somebody said to run the consumer. The consumer is set up with a property that relies on another task to be run. I need to add that task to the task graph. But I'm still not going to read its output file value. I'll delay that to the moment I have to actually evaluate the inputs of the task itself because it's ready to be run. Does that answer your question? The answer to that is it's complex.
Can you repeat the second question?
Oh, sorry. Yeah, the question is still a part is done at the execution phase. In the classical model of Gradle, yes, because input computation happens really when the task is executed. But if you use the configuration cache, which we'll talk about later, one of the things it changes is that it moves input evaluations to the end of the configuration phase. But aside from that, yes. So it's kind of, but the interesting element is that you should not care. Gradle has an execution model that allows you to work with that without caring about when exactly will the value be read. And if your implementation of the input actually cares, then you probably have a problem and you should figure out a way to make it not care, which is not always easy. There are corner cases, and sometimes it's worth opening an issue explaining the kind of corner case you have and like, could Gradle support that if you can't find a way to make it work?
But so maybe the summary is that all the wiring would happen before any first task is executed. So there is a barrier still between the phases. Any other questions? Yes, please. Yeah. Yeah, so the comment is that it's still very difficult, I guess the muscle memory not to type depends on. This is something to think about. I think as we continue with the provider API adoption, as Lou will explain in a moment, deprecating things that are not best practices would be one of the potential options, so that even if you do type that, you know, accidentally, you would be told that quick refactoring to something else would solve the issue, and you wouldn't really, that would be redundant to declare dependencies that way.
So what I was mostly wondering is how can I get visibility on that dependency is there?
Okay, so the question is, how do I get the visibility on the fact that the dependency is there? Currently, I know there are third-party plugins that will give you information about the task graph, but there's nothing inside Gradle. We've had conversation that with the provenance model of the provider API, maybe we should think about having like helpers that will allow you to effectively query, hey, I'm interested in the input of that task. Can you tell me where it's computed from? And of course, part of that information would be, this is a pretty direct mapping, right? But you can get way more creative than that. And so the idea would be potentially to give you the idea of that whole path in a digestible form. And of course, that would include then, by the way, from that branch of the path, you're actually carrying task information. One of the challenges is that you can do things that makes Gradle lose the task context. So yeah. It's definitely an ongoing improvement. But yeah, that's the go away pop-up. That's the goal. Yes?
So on line 17, you still have this flat map, and we use the functional programming that it's obvious.
Yeah.
You mentioned that the task container is generated. Could not generate some accessor directly for output file, so you can use the direct assignment of some synthetic sugar and then copy it on Gradle. Yeah. So you don't
Okay, so the question is about the fact that on line 17 we have to call flat map. What we have on the left-hand side is a container, and the question relates to the fact that that container is actually generated. So the container for the task container itself is not really generated. What's generated is an implementation of producer. So that still is the concrete task type. When we wrap them up, whether it's a task container or just the classical property, these are very generic wrappers. And so the question was about, couldn't Gradle effectively specialize those containers so that, so currently what we have here, if we look at the signature, is a task provider of producer. So couldn't Gradle do something like producer task provider? And then if you did producer task provider, then it could give you immediate access to those properties. I'm not behind the full design of that API, but I think for the moment, this is a more generic approach. Yes, you need to understand the map and the flat map from the functional, paradigm. Why is it a flat map and not a map? Well, again, it's basics, right? If you were just mapping, you would get a container of the value. The flat map is about flattening that. So I think it's mostly about the amount of classes we would end up dealing with, which might have other side effects. But that's not something we're considering for the moment. Mm-hmm. Yeah. No, so we don't have any specific elements, purely DSL-ish. And so here, one of the consequences of that is that your code, if you were to write your plugin or some of that build logic sorry, in pure Kotlin would look very similar. So it's true that we do not have sugar coating for the DSL that would allow some of that to be more hidden.
But we do generate a lot of syntactic sugar, and that will be something to consider as we continue on the adoption path for the provider API. And that last answer was for the comment that the Scala, just to mention it for the recording, that the Scala generates syntactic sugar for the accessors for things, yeah, even though they wouldn't have to be flat mapped, right?
Yeah. So just to give you an idea, the reason, so we're in Kotlin, which is statically typed, so the reason I can do task.producer is because when I apply the plugin, we actually see that there are more tasks registered and we generate accessors for them. So because otherwise you would have to do something like tasks.named or typed and all of that. So we already do some generation, but not to that level indeed. Any other question on that? Yes? Ha! So the question is, would this work in a multi-project build? The answer is yes, it would. Should you? And there the answer is no. And we'll see why at the end and what you should do for that. But yes, nothing prevents me from doing like accessing, like replacing tasks, I mean prefixing tasks here with my project lib. I mean, nothing prevents me from doing it aside from the fact.
You wouldn't get the accessors generated, or would you?
Oh, that's interesting. So it still thinks that I do have the producer in tasks in lib, which it shouldn't.
I mean, but the overall model is general enough between the projects, right? Yeah. The tasks are structured in the same way. So as long as you can reach the tasks in the other project, you can wire them, but probably you shouldn't.
Yeah, we'll explain why such a construct is discouraged later on in the presentation. Okay, so let me then.
Shall we continue with the slides?
Yep. I mean, no other questions?
Yeah, well, no.
I'm not sure I got the question, so to get some help, but.
Redeclaration. So they add an assert for in order to ensure lazy values are not redeclared. You mean that they are set multiple times?
Yeah. Yes. So if you want to do things like that, what you can do is you can always do that. So if you have a strong opinion that you should be the last one setting that value, you have a public API that allows you to say, from now on, this value is read-only, like I've frozen it. But that's a design choice in either your build logic or your plugin writing that will have consequences on their combination, but it might work for you, yes.
One more question?
That's again something that you can design.
So the question is that if somebody has already read the value, what happens when somebody sets the value later due to the laziness?
Yeah. I think by default that might work, but we definitely have ways when you set up your types to say, hey, this value, once it's read, I think it was just next to that other.
Yeah, we can try it out. I think the value is finalized once you read it, so there is no, in order to prevent that stale reads, the second time you try to set it would error out.
So one of the methods is disallow unsafe read, and as you can see, the Javadoc explains that the value of this property cannot be read during project configuration because we're effectively saying, hey, during the whole configuration phase, it could change any time, so I forbid you to read it. Like you can only set it, you cannot read it. So that's one thing. The other one would be finalize value on read. Thank you, Copilot. Like they're probably listening to us, right?
They do.
This was an interesting autocomplete suggestions given the current conversation. Maybe there is more AI in this talk than we thought. But yeah, so these are the two options you have And again, the reason these containers are flexible is because we know that there are different requirements out there, but you can control the flow of the value so that you guide your users or developers to the right behavior. Okay, let me delete that line because otherwise I'll forget and it will break next time. Sure? So the question is, should we do it always, or is it case by case? I think if you want to start with a much stricter mode, then yes, do it always. And you can do it again in the task implementation. You can do it in your extensions. So usually, what we recommend, is that the tasks pretty much don't care too much about that logic. But when you create those extensions that the users will interact with, that's where you will express those opinions. Yeah. But that's definitely, yeah, it's a valid approach. So I'm going to skip the next slide because that was the non-demo version of what we just discussed. However, let's be honest. I mean, you've seen it is a paradigm shift. Instead of just assigning values, we're asking you to do more. So there is an adoption challenge. Back to something that Alex mentioned at the start, the existing Gradle API is large, and it predates. A lot of it predates the introduction of those property and providers. And so that means we do have a lot to convert. What we've been doing so far is provide an alternative, which is always fun because some properties have actually, like getter setters in the current API, have great names, and providing an alternate means coming up with an alternate name. Then we would do a deprecation, of the classical getter setter in favor of the new provider-based, and then a removal. And the removal has to wait for a major. So two things here. First of all, it's disruptive, because you would start seeing, a bunch of deprecation warnings, and then you have to go left and right, and you have to rewire everything. But sometimes one part has been moved to the provider API, and where you wire it with didn't move yet, and so you have these mismatch of abstractions. And also, it's a very long cycle. And in order to, and the bridging is what I just mentioned. So in short, unfortunately, we figured out that it actually does not scale. And we want to handle that in a different way. One very good example of that, I think I ended up doing that deprecation warning, and we got quite a number of issues or comment on the issues. You used to be able to do file, open a string, $buildir, myoutput.txt, and that gives you a location relative to the buildir of the project. Except that this is a complete eager read. If you wrote that in the code and then you had the line I was experimenting with to change the build directory, you would be writing elsewhere if the build directory moves. So that's why we introduced that layout system where you can access the build directory and then you can get files directory underneath that. But once again, what you get out of there is a provider of a regular file. It is not something that you should toString, because it's a rich type and its toString is not the location. It's actually a string description of the provider and what it contains. And so if you have a migrated API on the left-hand side, then it's as simple as assigning the result, as we've shown in the demo a few minutes ago. However, if you have to deal with legacy APIs that either need a file object or a string, well, then you end up having to do these get, eager read as file, or map to the path, which for the moment still gives you a lazy string. And so you still have to get it potentially, depending on where you need to go. And so that's why we mean by it does not scale. It's really cumbersome, and you have to change the patterns. And the problem is we have to tell you, oh, the evolution is either left, if the left-hand side supports the provider API, or it's right, if the left-hand side does not support the provider API. And so that's not great. So what we decided to do for Gradle 9 is actually do a large-scale migration of the majority of the properties on task and extensions from the core Gradle plugins to the provider API. But of course, doing that means we break pretty much every plugin out there. And so our goal is to be able to support that migration by having some runtime adaptation when we will load a plugin that has been compiled against the Gradle 8 or earlier APIs in Gradle 9. We will try to change those getter-setter access to be actually setting the value or reading the value from the property. We also know that it will not be 100%, right? So there will be cases where that doesn't work because you're bridging an eager and a lazy world. And so that might cause changes in evaluation ordering. It also requires us to polish the provider API because by using it aggressively in more and more use cases, we're discovering shortcomings or things that are harder to use than we expected. And so that's another thing we're doing as part of that migration. But the migration itself in core Gradle does not resolve the adoption by the community plugins. And so that's something we'll have to pay attention to. Yes?
Have you considered using automated tools like providing open rewrite recipes for plugin authors or build logic authors?
Okay, so the question is, have we considered using automated tools like Open Rewrite so that we could provide recipes to plugin and build authors? Yes and no. Yes, conceptually, the idea. No, because, for example, currently there is no tool out there that supports the Kotlin DSL. So that's a limitation we have. I know they have people looking at that on the Open Rewrite side as one example. We know that organizations at scale that use the Groovy DSL have the ability to use the Nebula Lint plugin, which is a plugin done by Netflix that has those abilities. But it does it as part of the build. So for example, it does not apply to plugin logic that's coded as a project. So there are gaps there. So from the Gradle perspective, for the moment, we are not really looking into that directly. What we're hoping for is that we have the 80-20% rule, and that 80% of the plugins with like runtime conversion would work, and that 80% of your code would have some level of source compatibility. Yes?
If a plugin author upgrades a plugin to support Gradle 9, can they still support Gradle 8 at the same time, or is it just like one direction and give up?
Okay, so the question is, if a plugin author updates his plugin to support Gradle 9, can they still support the older versions? Yes, that's a side. It probably should have been a line on this slide. That's a side thing we're doing, is we're working on being able to publish the Gradle API so that as a plugin author, and also improve the plugin authoring experience, so that as a plugin author, you'll have the ability to say, oh, by the way, this code compiles against the Gradle 8 API, this code compiles against the Gradle 9 API, and then the packaging of my plugin, because of the dependency from the variant-aware dependency management system we have, will be loaded depending on when your plugin is applied. And so we want to improve the plugin authoring experience to allow you to do that much more easily than today. All the pieces, so for example, all the pieces in Gradle are available today. You can do it, but you have to understand all the pieces and wire them yourselves. And so we want to make that more of a directly usable by plugin authors. It will have the same limitation as multi-release jar and things like that. So you have to figure out how you compile elements and how you combine them so that they work properly.
One last thing to note here, maybe on a more positive note, is that, again, the provider API has been there for a while. And what we're talking now is about migrating the core Gradle plugins, where we try to be conservative, not to break people. But the majority of the popular plugins either already fully use the provider API or partially migrated to that. So the ecosystem adoption at scale is probably not as scary because it has been going on for a while. So it's more about addressing the plugins that either were in the corners of your large enterprise builds in your company, or or all the plugins that were not updated for a while. But yeah.
Okay. Any more questions on that? So just a quick recap of where we are at. So we've done this build comprehensibility. The next section would be build scalability. But what we could do, because it's been a bit more than an hour, is actually take a short break. So 15 minutes. We meet back I'm bad at math. Yeah,
No,
five before 11.
Yeah, sounds good.
And those who had a questions and want a cap, please come get them. All the others, there are stickers. Help yourself with them. If you have more specific question, you can also come ask us during the break.
Yeah, see you in 15 minutes.
Yep, see you.
Oh, wait.
Oh, we're back.
It
Okay,
seems we're
good.
back.
So it's interesting. You could not hear us yet, but looks like the transcript was hearing us and reporting. So that's funny. So thanks for coming back. As we said, let's move on to build scalability. Who has a long build? But let me ask and be more specific. I'm talking an hour and more. Okay, I already see one hand up.
Two hands up.
Two hands up. 30 minutes and more.
Okay, a bit more
Okay,
people.
a couple more. 5 minutes and more. Okay. Who considers less than a minute to actually still be long? Because that's the fun, right? With these kind of questions, absolutes are really hard. The philosophy we've taken at Gradle is to say that it's not that your build should be fast, it's that actually your build should be as fast as possible. And depending on the code you're building, depending on the test you're running, depending on the complexity of your project, depending on the complexity of the environment, like the exact answer might be vastly different. But we strongly believe that every progress we on the Gradle team can make to make things faster, or every progress you in your build logic can make to make things faster, will actually benefit your users. So if we go back to the product vision and highlight the scalability elements, one thing we would like to do is that size or complexity should not impact the fast aspect, the performance aspect. Because literally, most of the builds you run are never, completely brand new things. Some of the code that is being compiled, some of the tests that run, they actually executed or were compiled elsewhere already, and things like that. And so one of the guiding principles we try to have around that is that the overhead of the build tool, because unfortunately the build tool has some overhead, between the moment you start a build and the moment your first compilation task starts to run or your first test starts to run, that's what, from the producer of the build tool, we consider overhead, right? It's work you're not interested in. What you want is your compilation results or your test results. And we think that overhead should be proportional to the impact of the change. I mean, you upgrade to a brand new Gradle version. Yes, Gradle has to recompile all of that build logic because APIs probably have changed, some behavior can change. And so this has like a cascading effect on the up-to-date aspects of your build. But if you only ever changed the implementation of a test method, Gradle should be able to go really, really fast to just compiling that piece of code and then finally get to run your test. So between these two changes, you realize that they don't have the same impact. And so our goal is to make that overhead proportional to that aspect. We can't promise you that changing the whole build definition will be a snap. Like Gradle has to build that information in order to then apply some of its other benefits. The way we work internally is we try to think about use cases and do prioritization of the scalability benefits according to those use cases. An obvious use case for a build tool is what we call the inner developer loop. You're coding, you're building those changes and then testing them. This is close to code test refactor. I mean, it's what, as a developer, you would be doing daily. But of course, there are other loops. And the outer developer loop has a number of things. Syncing. You're coming into the morning and you're getting all these changes from your colleagues that happened yesterday, trying to, be as close to the latest version of the project that you can be. You have to integrate all of those changes. You're pushing that merge request towards CI so that you can validate that it actually doesn't break anything beyond what you tested locally, because you do test locally, right? And you have also the challenges of methods like ephemeral CI, which I think my earlier comment indicates that I'm not fondly in love with. But these are elements where suddenly Gradle has to execute in an environment that is absolutely pristine. Like it lacks all kind of pre-computed information, and suddenly it has to do a lot more work potentially. So these are one element, the use cases. Another element is that Gradle itself has to do a number of things. There is a Gradle startup, which is the ability for the launcher to actually either create or connect to an existing Gradle daemon. And so that involves starting 1 or 2 JVMs, potentially. There's the whole phase of the configuration. Gradle is figuring out, based on what you requested on the command line, or based on what an IDE requested in order to present your project in that IDE, what it has to do. And then finally comes the execution phase, where Gradle is actually delivering its more useful work, that is doing the tasks related to your development activities. This is a very high-level diagram of that. The bars are not to scale. There are pathological use cases where that startup phase can actually dominate your whole build. And of course, what we would like is that most of the time, the execution phase is what dominates. Because, like, let's be honest, again, in terms of phases, the first two are overhead. So how do we deal with that? Well, we've got a bunch of different strategies. One of them is purely performance. And those strategies are linked to different focus around performance. One of them is work avoidance. The work you don't have to do is the best, because that one is cheap. Like, it's actually free. If you don't do it, nothing needs to be executed. And so we're trying really hard to minimize that unnecessary work, hence enhancing efficiency. And the other one is adapted to the hardware we know today, like parallelism, by just making sure that the wall clock time of your build has nothing to do with the total time of CPUs it actually leveraged. And so that's concurrent processing, right? Run your test in parallel. Like, can we actually compile the project for the client while we also compile the project for the server? Like, they shouldn't have any relationship and things like that. And so these are all features that have been existing in Gradle for a number of time, up to date, task checks. That's something that actually really sets Gradle apart from the competition in other build tools. We have that ability of understanding these are the inputs, these are the outputs. They didn't change, the output is still here, the task doesn't need to run, there's nothing to do. We can completely skip its execution because it obviously ran in the past, the local state is still available on disk. Hey, let's give you the result to the next task in the chain. That actually evolved to another thing, caching. You're actually switching branches, but you had run that other branch you're switching to 2 days ago. And the code of some of the modules didn't change. Well, Gradle cached that information in its local cache, and so it can restore the outputs from the local cache based on the key computed from the inputs. And so once again, why would we rerun all of that execution if we can restore it from a cache? I mean, of course, it means you're using tools that are reliable. But if you have that, and most modern compilers, most modern tools we have on the JVM ecosystem have that property, it's an amazing result. And of course, what we did is we moved also the cache beyond local. We moved it to being remote. So now you have the ability, in the morning, you update your code, you've got the latest that was built last night on CI, and when you start your first run, what happens is that the most time-consuming tasks, instead of running locally, are just about downloading these outputs from the remote cache and replacing the data on disk, and then moving on. And then another element that you can do in Gradle, you have that concept of incremental task. This is a bit more advanced, but you have the ability to code a task in a way that when Gradle sees changed inputs compared to the previous time, instead of telling you you should run, it gives you a list of change events and say, hey, these files were added, these were deleted, these were modified. And then your task logic can decide what to do. Some tasks apply very well to such a pattern, others not at all. So that's an implementation detail, but when you can provide that, you've got something that's not up to date, but instead of processing everything, you only process what's needed.
So many of the core plugin tasks like Java compilation make use of all of that in order to make sure you get the optimal performance.
Yeah. Maybe 2 more slides, a bit on the product side. So if you have Develocity, which is our for-pay solution, you can actually add even more work avoidance techniques. One is that the remote cache can actually now be replicated. And so if you have a distributed team, you can make sure that you have caches that are closer to the different teams. Because, of course, one downside of a remote cache is that if your network connection is really bad, then you may not get benefits. It might be better to run work locally over downloading it. And another feature, maybe one more tiny bit of, I mean, it's AI, but it's more machine learning, is we have a feature that's called predictive test selection. And what that feature will do is that based on the change set, it will have learned, based on your past execution, what are the tests that are the most relevant to validate that change. And so it will allow you to run only a fraction of your tests. And of course, that will speed up your feedback loop. This does not mean you should run with that on the production pipeline, but at least for local developers and for quick feedback, it's a very, very useful tool. Then, as I was saying, the other side of that is execution parallelism. The first thing that Gradle introduced was parallel test execution. So you had the ability to say, hey, I want to fork for my tests. I want to use a different executor for test classes. You have ways to control them so that they are reused a number of times before being abandoned. And all of that sometimes depends on how your tests are set up and what kind of shared infrastructure or services they have to use. But again, if you can, make your test parallel. That will speed up things. One of the reasons in the past I moved from Maven to Gradle was because we moved from 4 hours of full test suite execution to 45 minutes, just by switching build tools. Like, we did not rewrite anything in the tests. Parallel task execution. So Gradle has had -- parallel for a while now. And so what that allows to do is exactly what it says. You have multiple projects. These projects, we've seen that task graph. Part of that task graph can actually happen in parallel. Let's do it. And the -- parallel does that at the project level. So task will not run in parallel inside a project. And then the worker API, which is the latest addition, but we're still talking Gradle 5, right? Just to be clear in terms of time frame. The worker API is a way for you to implement your tasks and say that the work defined by the task is actually spread on multiple workers. Develocity has one more feature on that. It's called test distribution. And so here the ability is to actually not run your tests locally, but run them on remote agents. And that gives us, for example, inside a Gradle team, I think we have a couple hours of dependency management test, and you can run all of that in 10 minutes from a local invocation. And then you have a full execution of all the integration tests after you do a change on dependency management. So that's really, again, powerful. So that's kind of a history of all the different things. And so now I'll leave it up to Alex to explain the kind of things we're currently doing with Gradle.
Yes, so as Lou mentioned, there are a number of ways to do work avoidance in order to speed up the build. And looking at the overall picture of the build, the configuration phase is also something that takes time, and people face that time being spent not doing the useful work. And there's a feature for that specifically called Gradle configuration cache, which is both about the work avoidance and also about parallelism. Just a quick reminder that what is configuration cache. So it's a feature primarily designed to speed up that inner developer loop of change, test, and build in order to get the quick feedback after you do the changes. And it does so by actually caching the whole configuration phase that ran in order to, the next time, skip the configuration entirely and continue with executing the actual useful work when you do the subsequent builds. But we say configuration cache, so what does it actually entail? What do we cache? So as mentioned before, Gradle execution model is based on tasks and specifically on a task graph where tasks have relations. So in order to execute without the configuration phase, we still need the task graph. So this is exactly what we store. So everything before the task graph gets discarded, and everything task related, such as task instances or specific task inputs, that is what gets cached. Everything else, such as the project state, any plugin state that has been there during the configuration, is discarded, and the benefit is there at the same time for a cache miss. When you didn't have any cache entries before, we can discard that state much earlier and then continue with the rest, slimming that layer of memory used by the build. But also when you get a cache hit, we entirely skip all the memory overhead of the configuration phase as well, and then making your build even faster and less applying less memory pressure. Right. So one of the examples of how you would migrate to using configuration cache, or something to watch out for, is using the types of the Gradle configuration model, such as source set, which is intrinsic to the project structure that contains a lot of information about the project, the files themselves, and so it's a heavy type in that sense. But previously, what we call vintage Gradle, nothing would stopped you from using that as an input to a task and was perfectly valid. But the problem is it brings all of that state into the execution phase, so that state lives and cannot be let go even during the execution time, only much later. So those things have to change. The new APIs have to be adopted, such as replacing the source set with a file collection. In this case, since it's a mutable one, it will be a configurable file collection. And previously, in order to get to the actual files, you would have to go through the file collection anyway. So in the example above, that would be the compile class path, which would be a file collection. But now you have to lift up that state, that is the configuration state, into configuration time, and unpack only the necessary bits and use them as inputs. So getting back to the input-output model, you have to really make sure that your inputs are as small as possible, so only the relevant changes are applied. And then after you update to the new type, you can set the compile class path directly as an input when you configure a task. And now let's see in action what it actually means and how configuration cache can improve your inner developer loop. Let me switch over to that computer over here. Let's see if that picks things up correctly.
You may want to move a bit to the left. You've got the screen in your face, so if you...
Right.
Yeah.
Okay, so the example I want to show is the applicability of the configuration cache feature on the Gradle build. We do heavy dogfooding of majority of the features we do in order to make sure they're quality, but also because they really improve our own lives, and there's just no reason not to be, happier. And so let me start with the Gradle Build Tool project is actually a non-trivial one. So I'm in the settings script here, just looking at the number of projects overall. This is obviously a multi-project build, so there are about 200 projects, but that does not even include all the build logic we have, of which we have a lot, more dogfooding there. So it's a non-trivial build, but in terms of the regular workflows we do as developers, they are the same as yours for regular development. So let's take a look at an example of an integration test, actually a functional end-to-end test that we have, an enormous amount of in the Gradle code base. It works pretty straightforward. We create files on disk that represent a build under test. Then we run the tasks that need to be run and verify that the final result is what we expect. So this is by no means not a unit test. But if I just run that test, even though it's part of the large Gradle build overall, what I get is running the test took just 1 second compared to the whole build size. And what I expect is when I do any change to the test, like that, and if I rerun the test, my developer loop should not be interrupted by any overhead or visible overhead, visible enough that I would go get a coffee. So yeah, even after changing the test, the execution is still around seconds. And that applies to obviously changing the production code as well. So that's Java compilation related. So if I go and yeah, already had something there. So I had like a print line in the Java compile task. So if I comment that out, that's a change to the production code. So when I rerun my tests, they must pick that up. But what I expect is the execution to be as fast if I ran it previously. So let's see. Yeah. So that was about 12 seconds. And if I keep on, rerunning things, the overhead would stay as small as possible. But again, there is a difference between making the inner loop changes and external developer loop changes. So if I have to say change something in my Gradle properties on a settings files, let's say I change a property to make a little bit more of the JVM memory, and if I run the test, that then would have to do a lot more work because Gradle properties is something that is accessible to the whole build. So I have to wait much longer in terms of the overall configuration overhead that I have to use. Right. Was there anything else I wanted to show? Yeah. Another thing is, yeah, it keeps on going. Another thing, when you run tests, right? Iterating on one test is the usual case, but sometimes the tests are grouped and you would want to test the same functionality from different angles. Running the other tests in the test class would also get configuration cache hits. So after we executed this, oh, sorry, that was an old one. I closed the previous one. If I run a different test, it should pick up the configuration cache changes. And we can probably see it at the top of the build. Yeah, right. You can see it's reusing the configuration cache, even though I ran a completely different test in a test class, and you still get low second time execution.
And so, I mean, this is literally more than just different test in the same class. It's actually the moment you use the same test configuration. Like we've got multiple execution of tests because we run them with and without configuration cache and things like that. But so let's say in a classical Java project, you run the test task and the only thing you change is the test filter. So which test task to run, or which test classes or test methods to run, you get a CC hit in the IDE. The day we had the full chain, because that required changes in Gradle, but it also required changes in IntelliJ in the way it would invoke those tests. But the day that full chain was working, that's a life changer when you have like non-trivial build size where the build logic, even if it's fully up to date, can take between 20 and 40 seconds before you get to the test execution. Because that's disruptive. When you click that green button, like you're gonna wait half a minute for nothing and then finally get your test results. So it's yeah, use it if only for that.
Yeah, in terms of some things we are looking forward towards, integration between Gradle and IntelliJ is, for instance, the ability to reuse configuration cache when you run your tests versus when you debug it, because it's effectively using the same test configuration, but it's still tricky to get it working, and this is something that will probably come in the future, but it would keep on improving, keep on extending the scope of that inner developer loop that we wanted to optimize. I think that's it for the demo.
Okay. Give it a sec.
Yeah,
oh, that's interesting.
Right, but improving that, like introducing this work avoidance of skipping the configuration phase is not the only thing that you get when you enable configuration cache. The other thing is actually you get that task parallelism for free or as an additional benefit. And to complement what Louis mentioned before about the -- parallel flag that only enables running tasks in parallel from different projects, Configuration cache allows to run tasks from within the same project in parallel as long as they are not dependent on each other based on the task graph. So that means, well, running almost everything in parallel when it comes to execution phase, which is the benefit that comes even for the invocations with a configuration cache miss, because the way configuration cache works, after it determined all the dependencies, it goes through the store and load cycle. So even for the cache miss, the execution will always be parallel. So that could be useful even for command line invocations. And as I mentioned previously, discarding the state earlier, much earlier, or not using that at all for the cache hits means that you would use much less memory, putting less pressure on your system, allowing you to run Spotify without chugging on your music. And yeah, the question is, how easy it is to adopt. Can you use it in your build today? So that still depends on your build. The adoption could still require some changes to your build logic, but as mentioned, the most popular plugins out there have already adopted. There is also a clear signal, for instance, from the Android community that top applications adopt it heavily because of the benefits it brings and the high configuration time that they experience. But even though it's hard to adopt it fully because it either works for your build or not, you can go on a task-by-task basis to adopting the configuration cache incrementally, because we know that for different workflows, you use different tasks, and the developer on a local machine wouldn't probably use all the tasks that run on CI.
Oh, we're back.
Okay, yeah, we're back. Nothing changed on the slide. So yeah, there is an API, for instance, to mark the tasks as non-configuration cache compatible, and you would still be getting configuration cache hits as long as these tasks are not participating in your task graph. So you can split out, for instance, some quick tests that you run locally as a developer to always get that configuration cache even before fully migrating to the configuration cache in your build. Yeah, and again, all the things that we expect you to adopt for configuration cache are not only for its own sake, they are actually enablers for maintaining your build easier and unlocking more features down the road.
Before you move on, Alex, I realized that we did not fully introduce, kind of the curse of knowledge, we did not fully introduce what is a configuration cache, yes, but like, are you aware of it? So who already tried the configuration cache?
That's a good one.
Okay, but cool. So we've got a number of folks.
Yeah.
Who is absolutely confused about what we just presented?
One question, is it disabled by default?
Yes. So it's disabled by default, and that's probably one of the... So the question is it disabled by default? The answer is yes. The reason is, and that's something that I realize we're missing here, in order to give you the configuration cache, Alex showed you these patterns that don't work, but it also has changes in the Gradle model in a way, and so you need to adapt to that. And so that's why turning it on by default is something we want to do in the future. Alex will get back into our plans there, but you have to enable it, and it will most likely fail. If it doesn't, great, just jump on it, and you should turn it on like tomorrow. But if it does, you have to follow some improvements there. There was another hand raised about being confused. Any question we can try to answer?
Yeah, so the question was whether configuration cache is going to be the default. And in fact, the plan is to, in phases, to get to the point where this is the only way you run Gradle. But we're going to do that respecting the deprecation cycles and incompatible changes. Specifically for the plan, I don't think we have it there later. So we're going to make, the current plan is for the 9.0, we're going to make configuration cache what we call a preferred mode of execution. So it will not be enabled by default, but we'll start adding messages inviting users to enable configuration cache. At some point during the 9 timeline, we're going to deprecate not enabling configuration cache, but it's still going to work for you. So you would still need opt-in and migrate your build. And then sometime later, not necessarily Gradle 10, but we'll make it enabled by default. So that means, yeah, your build would just keep on using that, and maybe down the road we will effectively remove the option to opt out, making that like the way Gradle works effectively. And in terms of the adoption, for instance, or where we enabled it by default, the build init plugin that Louis mentioned before that allows you to generate small starter projects already enables configuration cache by default in the properties as the best practice as reviewed.
In 8.11, which is to be released.
Okay, yeah.
But for us, it's doing it already, but yeah. And so just like, again, that last line on the slide really matters. The configuration cache is really about applying best practices, because what it then allows Gradle's execution engine is, for example, there is no opt-in to -- parallel with the configuration cache. If we can isolate your task inputs and your tasks, then we know their execution is parallel safe, because there is no project state that can be still that mutable shared state that your task is accessing. Everything is isolated. We know their independent execution elements, and so we know we can run them in parallel. That's why activating CC has effectively the effect of activating -- parallel with the added parallelism benefit that Alex just presented. So just again, setting the context.
Yeah. All right. And in terms of the adoption, the way we approach, like letting you know exactly what to fix in your build, is by providing extensive and interactive reports. You maybe have seen already since the configuration cache was around for quite some time, but it was not, staying there in a frozen state. We keep on adding even UX improvements to the configuration cache report. For instance. Recently we included the name of the build and clarified the tasks that you're running. We added the reason why the configuration cache had a miss, so that you understand exactly what changed, why did you have to wait longer. And it's also a good place to track exactly what inputs your build is referring to. You might be surprised how many things the build reaches out to without you probably knowing, running some third-party binaries or reading some files or system properties you had no idea it was reading.
We had a user report that they had issues getting CC hits because their .git folder was an input to the build.
Well, yeah.
So, yeah, and the question was why, rather than should Gradle fix anything. But that's, yeah, so, and it will tell you, that's a benefit.
Wild examples in the wild. Sorry, I didn't bring that up. Is this enabled by default? So whenever you enable configuration cache, every run of your Gradle, however it is done, it produces a configuration cache report. There's going to be a link to a local file in the build output whenever there are problems in the report, like things you have to fix. So it's visible. You can always navigate, open that in a browser. And if you have no problems, the report will still be there. It will be in the reports folder, as you mentioned. Yes. Yeah, and speaking of more UX improvements, we also added more compact stack traces that also point you to the likeliest place where the actual problem that is not supported by configuration cache occurs, bringing that line to the top. You can also copy and paste the report around. It preserves the formatting, so you can share it with your colleagues when you're debugging something together. And yeah. Configuration cache report is something to recommend. And recently, I think it was 8.10, we also added an additional tab to that, also letting you know the things that you left behind in your migration, so specifically tasks that you marked as incompatible, but now they are part of the report, so you know what else is needed to become fully configuration cache compatible and stay that way for longer.
Yeah, in the Gradle zone build, our documentation generation is still not yet configuration cache compatible. I have to execute that often around releases. Trust me, this is really painful. I want it to become compatible one day, but it uses a number of plugins that have their own mechanism from long ago, and so yeah. So there are still challenges, but like Alex was saying, he showed you CC on Gradle's own build for the inner developer loop. We don't have it yet for the publication of the documentation. So, but still, it's the same project, just different set of tasks, and so one can work, the other one doesn't.
But once you know how good can it be, it's, you know, every time you're reminded how slow can it be, it's really painful.
And if you have build scans, all the things we're discussing are actually also in the build scans.
Yeah.
How much do you expect it to help for Gradle's documentation build? Just like, is it a big improvement or is it like?
You remember that diagram where we were showing the build startup, the configuration phase, and then the execution? Configuration cache literally removes that configuration phase completely. I mean, completely, minus the loading time of the configuration cache entry. And so what Alex was showing you, when that build took a lot more time, that's because the configuration phase was running. So effectively, whenever I run a documentation build, even if I don't change a single file, it's going to take that time to tell me that it now starts the documentation, oh, everything is still up to date. And so I end up spending 20 seconds just being told everything is up to date, you're good. Yeah. And so that's the kind of effect we're talking about.
Right. So the question was about migrating the like that documentation, whether we actually want it, and yes, we want it because the configuration time is sort of shared whatever task you run. But yeah, we don't want to spend that time waiting when we run documentation tasks. Yeah, for a bit more advanced users who already adopted configuration cache, there's more things you could do to optimize. Getting back to, is your build as fast as it can be and as resource efficient as it can be? So you can actually use the tool that we have that maps the state of the configuration cache entry that we store, which is, you know, all the objects of the task graph, whatever it references, on disk. And this tool allows to convert that state into an interactive interactive diagram of exploring like the state as a stack trace, which is called GCC to Speedscope, which we know was really effective with some larger teams that that had enormously sized CC entries, like we're talking gigabytes, and yeah, and that allows you to spot probably, you know, there is always 80-20 rule, spot a few things that bring on again not a forbidden state, but just unnecessarily large state to the configuration, and cutting that off would reduce your entry sizes, which would consequently improve the store time, less things to write, the load times, etc. So it will improve the configuration cache experience even further. One question that we get a lot is whether CC, you know, is good for CI, whether people should use CC on CI. And when we introduced CC today, we said that it was primarily designed for improving this inner developer loop, and we really mean it. And the CC on CI has a number of design complications, because CC works that way that it stores all the information in terms of the local references it needs for dependencies and whatnot in the entry, and in order to make that relocatable, make that reusable on CI, it would mean bringing much more state into that entry, and that is currently not supported. So the bottom line about CC on CI, it's not officially supported. We don't necessarily recommend using it, but we know of some companies that are able to do so, although it requires an enormous buy-in, replicating the environment exactly down to your build dependencies, etc. But if you have a large enough build, that still might provide visible enough benefits for you to see. Yeah, so to sum it up in terms of the benefits that you get, it will still depend on the build that you run and the tasks that you run in the build. It's not only about avoiding that configuration phase, the tasks run in parallel as well. So you get both work avoidance and parallelism, less memory pressure for your builds. And yeah, the builds of different size would have different benefits, and the larger your build, probably your most pains are with configuration times themselves. So reducing that would improve things. And for the small builds, it's for running those, say, enormous number of tests, running more of them in parallel if they are running in different tasks, even within the same project, would help as well. And we have actually some folks shared publicly the benefits they got from the configuration cache. So the block company that has a Square product has a really large Android project that is thousands of modules. And back in 2022, when configuration cache was even before being stable, they already saw enormous improvements in terms of the performance they got and the savings they got throughout the company running all the things for their developers. But since then, configuration cache was not frozen in terms of development. We've been adding new things. We've been improving performance. So even if you already are configuration cache compatible now, but you use an older version of Gradle, just by upgrading Gradle, you would improve performance of the configuration cache in your build as well. As some examples, the 8.10, the most recent release that's out there, makes it so the configuration cache entries are actually sort of compressed. That works through deduplicating the strings that appear in the configuration cache entry, of which there are plenty during the build time, which includes things like class paths, class names, and whatnot, and that shows significant improvements. And since the configuration cache entries are smaller, as I noted before, the load times improve and the overall pipeline runs faster. The next release that's around the corner, 8.11, comes with even more exciting things. So parallel load for configuration cache entries is something that runs and would work specifically well for multi-project builds, because configuration cache entry would be cut into pieces, effectively one per project, and then loading that state up in parallel would allow us to run things much faster. The reason we can introduce that improvement without an opt-in, so it's going to be enabled by default in 8.11, is because after we stored everything on disk, we know that loading is safe in terms of the parallelism, because, well, nothing can reference each other. Everything was serialized separately, so that's safe. The other part, though, the storing time, is not safe, because during the storage time, things could refer your state. One state can refer to another state, so doing that in parallel without verifying that it doesn't break your build or providing that guarantee is not something we can do, but we provide that option to run the configuration store in parallel as well as an opt-in.
Just to be clear, if you were using -- parallel before, there is a high chance that you should turn on that feature.
Yeah.
We decided to not reuse that flag because then it would be confusing. It becomes a flag that has multiple meanings. But literally, the documentation of 8.11 will tell you, hey, this is an option if you were using -- parallel. Strongly consider trying that out because it most likely will work. Yep. And so once again, right, you've adopted configuration cache and you get those benefits for free as we continue improving it.
Yeah. One thing to mention about the parallel store. So the store story itself, how long can it take to write files on disk? But the other difference is that the dependencies of the tasks that are being stored per project are also resolved in parallel in that case, which before you could have seen only with a -- parallel flag. And sometimes these dependency downloads are the dominating factor or a significant chunk of your configuration time, which you might not necessarily even knew about. But doing that in parallel can significantly speed up your build just by that. And the improvements don't stop there. So like even after 8.11, we have something we are actively working on. And one other thing would be to deduplicate not only strings but other structural aspects of the configuration cache, of the configuration model of Gradle, such as dependency management information, for instance, capabilities and whatnot. So the structural values that are reused everywhere, but currently are stored separately per project where they're used. And deduplicating that would make sure the storage for the configuration cache would be even more efficient, again, bringing all the benefits I mentioned before. And to get a bit more specific, that information is also available in 8.10 release notes. When we tested that, again, dogfooding on the Gradle build, we saw like all of those are improvements. So we saw the reduction in time in terms of the time it takes on a cache miss. So that's almost 3%. Hit rate, not the hit rate, sorry. On a cache hit, when we only do the load, because the storage is so compressed, we get almost a fifth of the time cut off in terms of the waiting for the configuration phase, and the storage obviously itself improves for our case by half. And we also tested that on a much larger projects, because we know for Android ecosystem configuration times are something people are really looking forward to improving, and there the improvements are similar, and you can, again, when we're talking gigabytes of state, reducing that by half or more is really significant in terms of the savings in time. So to recap where the configuration cache feature is, it is widely adopted already by the ecosystem and the community. It's been out there for a while. It became stable in 8.1. Since then, it still saw a number of improvements in terms of performance. It kept getting easier to adopt with richer reports, with better guidance, with more fine-grained details on what changed in your build and caused a cache miss and whatnot, better integration with build scans, and last but not least is adopting configuration cache and best practices it expects actually would unlock even more features that that will come in the future Gradle versions that would speed up your builds even faster. Right. And with that, yeah, let's take a look at actually what comes next, not even necessarily in Gradle 9.
Yeah. So before we, peeking into the future includes Gradle 9, right? So we're going to do a quick recap on the Gradle 9 objectives. But after that, we didn't want it to leave you without, showing a little bit the current work that's happening, which is not necessarily tied to a release. So let's start with Gradle 9. So as a reminder, we've seen core updates. So Java 17 will be the minimum for the Gradle daemon, Java 8 for workers. We had a question at the break that Java 8 applies also to the tooling API. The tooling API is a way to interact from a single library, which is used by IDE vendors, but there are other use cases to many different Gradle versions and just like do queries that are not just about task execution, but also about getting the model about the Gradle build, which is what an IDE needs in order to represent your project inside the IDE. And so there as well, Java 8 will be the minimal version. We'll move to Kotlin language 2.0, including K2 and availability of the language for the Kotlin 2 language features in your build logic. Planning to move to Groovy 4. Tools and libraries updates I've already discussed, and many bug fixes and improvements. So that's the core things. Then if we go on the comprehensibility elements.
Yeah, there we have the provider API that we talked about. So we call it provider API 1.0 that will come with Gradle 9 and the migration that it entails. Right. We would also work on the Surface API itself, supporting even more use cases, such as making the collaboration between the plugins better and covering more invariants. And the migration, as mentioned, would be a best effort support for the binary compatibility with third-party plugins that did not migrate to provider API yet. And we know that for some cases, the build logic that you have might be compatible actually even after the migration. So you might not need to change it even though you upgrade to Gradle 9. All right. Sorry.
Yeah, let's do a mention. So the problems API is something that we did not really focus on, but it's effectively the underlying system that was supporting all the changes you've seen around these help messages. And the idea with that problems API is to make it a public API. So some pieces are already there. It's limited in terms of what a plugin author or a build author can do and the effect it has on the build output. But this idea of showing you compilation errors at the end of the build, that should be done via purely public APIs soon. And so that means you as a plugin author will have the ability to do similar things, like give us a message that has structure. Hey, here is the message to the user. Here is a potential fix. Here is a link to relevant documentation on that specific topic. Public API for doing deprecation warnings in your own build logic. Like you're evolving that build logic, you've got projects that are using it, they can't migrate instantaneously. You will be able to have a deprecation cycle for your own plugins, for your own internal company's build logic. So we want all of that to effectively become something that build authors can opt in and have all the benefits of this better rendering on the authorsAll output. They will go as rich events through the tooling API, meaning that the IDE will be able to render them properly in the different views of the IDE. So yeah, that's definitely something that's ongoing. We put it under the Gradle 9 umbrella because there is a goal of being done there. But because this is new APIs, they're not breaking changes, right? They're new features. Some of that gets delivered in the upcoming minor releases that are still going to happen in 8.
Yeah, so look out for those if you're interested in them. In terms of the scalability, we talked about configuration cache and how there's no reason for you not to use it. There is only the benefits and more benefits to come later. Yeah, and also overall, we didn't talk about it a lot, but again, even outside of configuration cache, Gradle sees the performance as the feature, and we have an extensive performance benchmarks with every release, and we track that performance and improve it over the releases. So again, even if you upgrade just to recent 8 versions or to Gradle 9, you should expect performance improvements overall.
And then if you want to follow a bit more the details, so current timeline is Q1 2025. This is software. This might change. We have a Gradle roadmap. If you go to roadmap.gradle.org, or if you search the board on GitHub, you'll have a page that explains the roadmap. Then you can go to the board, and you can see the current initiatives where we have in progress, and how they move forward, like which features end up scoped to which release. And of course, I mean, this is software, so sometimes we decide to delay something a bit longer because it's not fully ready. Other times, stuff actually gets delivered a bit faster than expected. So if you're interested, that's a high-level view. If you're deeply interested in some specific features, then the issue tracker is probably your place to go. But that can be daunting in the number of issues it contains and sometimes the specifics. So in short, that's it, the road to Gradle 9. But that's not all we're doing. We have a number of ongoing initiatives that we think are still really relevant, and they'll show you also that some of the things Alex was saying about the fact that if you adopt a feature, you're getting ready for the future. And the first one is isolated projects.
Yeah, you might have heard about this before. You might have been hearing about this for the first time here. So let's start from something we have an anchor to, which is configuration cache. And configuration cache, even though it brings so many benefits, it still has some limitations, right? We talked about that if you are not necessarily a developer, if you have to put on your build engineer hat, change some build logic, change dependencies, that would affect your configuration. So when you do those changes, you would get a cache miss. So it means you still have to run the configuration phase and pay that price. And after you know how green the grass is on the other side, you don't really want to keep doing that. So a cache miss, right? How bad can it be? Right. So as I said, the configuration phase has to run. There's no way to restore it. But we can find better ways of slicing the state that we're storing and introducing a bit more constraints, we can expand the scope of the parallelism that we can leverage, as well as cache things in a more incremental fashion, so that reuse, even on the miss, would be much more significant. And this is what the Isolated Projects initiative is about. And its main constraint is that you should not, or you cannot access mutable state across the project. That kind of ties back to the question before about the tasks from a different project. But the good thing is, this is the only thing effectively that we expect to change, right? As long as projects are not communicating with each other directly by touching the mutable state of the project instance, things should be good. But let's look at the specific examples of what that entails. One of the most common cases probably that we saw in the build, and you might have in yours, is applying mutable configuration where all projects call back. And here we changed the group. And normally you would see such a code block in like a root project that would just set the group for all the other projects. But that's exactly the problem, because the root project now knows all about the rest of the projects. And if we talk about incrementality and we think, root project could be cached because nothing changed, if we skip that part, it would mean a different state for the other project. So we cannot. And that's why that's something what we call a violation of the constraints of isolated projects. So that's not going to be allowed. And by that I mean changing the group. Calling all projects by itself is not a violation. So like getting a reference to another project is fine. It's touching the mutable state That's the most important thing. So it could be more direct. So for instance, you could be in a sub-project, and again, you're sharing the state, such as the version that you want to have to be the same across all your sub-projects, and you assign that from the root project. And here we reach to the other project, but in the other direction. We reach to the parent, but again, version is something mutable. So for instance, talking about laziness again, version in the root project is a mutable thing. And if you read here through the eager API, the value, it could have changed later, and then the discrepancy could be hard to notice if it's something less trivial than the version. Another example is exactly reaching for tasks in another project. So if you do have to use depends on, and you find your task through the APIs and you get that reference to that task, that's also a violation, because the tasks container is a mutable thing as well. And so when you did that wiring here, you might not have found the task or found one, and either it will be removed later or things could change later in the tasks container when things run in parallel, which would mean you would observe a flaky behavior. So we cannot allow that. So the task container, which is mutable, is also a violation with regards to isolated projects. And the reason why, again, it's a different constraint. You would have to pay the cost of adopting it, but we believe that it matters because it brings performance benefits, and we want to demonstrate that, of course, by delivering them earlier rather than later. But performance benefits are not the only part of the picture, right? We also need to potentially introduce new APIs or patterns of using Gradle that are not conflicting with the constraints, so that you can actually adopt it. But again, you adopting that thing might not be enough. You might discover that the ecosystem needs to adopt, and so we would see similar challenges that we had with configuration cache being a major feature in terms of the adoption. So with isolated projects, we are taking that feedback into account, and we are much more cautious in terms of getting the feedback earlier and making the adoption as incremental as possible as we go. So in terms of the current overview, where we are with the prototype, and yeah, isolated projects as a feature is an alpha experiment now, so you can already play around with it, see some benefits, but it is definitely not ready for production, and its scope is rather limited at the moment. So we are focusing on, in terms of the things that I mentioned here, we try to attack each direction incrementally as well. So we make progress on all the fronts, so that you can see the thing working all the way through, and then we continue to expand. So in terms of the adoption, we're starting with the simplest thing for the Gradle Build Tool, which is the Java project. So if you have a Java-only project, such as, for instance, a backend or a library, you might see that already working for you, and we'll see how to enable that in a minute. We know, or we're collaborating with Kotlin team and Android teams to make their plugins also compatible. That will take a bit more time, but they are in this adoption is in active development, and the teams are also really excited in terms of the benefits it could bring. And for the rest of the ecosystem, some core plugins, such as the validation plugins, check style, PMD, and Conarch also are already migrated, and we are continuing the dogfooding side in the Gradle projects, but other core plugins are not yet migrated. So depending on what you use, it might not be there. We know that some of the community plugins that keep an eye out for latest Gradle features have already started adopting. So if you're a lucky user of those, that might bring you closer to adoption as well. But the community will catch up as we introduce, as we make the adoption easier as well. So in terms of the performance benefits, we also want to slice that into deliverable chunks, so that even before we deliver the full picture, you can still update to some minor versions and see the benefits. And one thing we already mentioned before is this parallel store for configuration cache, which requires an opt-in if you're using configuration cache. But if you opt in into isolated projects, that comes for free, because the constraint that isolated projects brings is strong enough to guarantee that your build logic is not coupled, so it can run in parallel, and that's why we can benefit of that immediately. And then going forward, we see the two major improvements that isolated projects brings is the parallelization and incrementality. And in terms of the different use cases that we mentioned before, the sync use case, so this outer developer loop that sometimes we have to face, in the morning we also want the build to sync faster. This is what we're focusing on first. So we want to make sure that when you sync your project in the IDE, it can go as fast as possible. It has some complications because it works through the tooling API, and it means integrating that all the way through. So it's not only the Gradle side, it's also the IntelliJ side that needs to be adopted, but we are actively collaborating between the teams to get it delivered. And as of Gradle 8.11, for which there is no release but a milestone you can try, the things checkmarked here are already working for the limited scope that I mentioned before. And last but not least, in terms of the parallel configuration, is when you run your tasks on the command line, say you run tests, or even one that runs on CI, you also get the benefit of parallel project configuration. The next step that is further ahead is making that also incremental. And by that, I mean, even if you could configure everything in parallel, you don't have to configure everything every time. So again, if you run only a single task in a single project, do you really need to configure everything else? And before isolated projects, we didn't have that luxury, because any other project could have tapped into the project you're running and changed something that would change the behavior. But with isolation, we can be certain that it's no longer the case, and we could even skip the configuration entirely, or when you rerun and change like smaller things in other projects, we would reconfigure only those projects. And that incrementality also has two dimensions, which is working for sync. For instance, when you change the dependency, you want to see that source is loaded, etc. So you have to tap back into the sync loop and wait for it. So we want to make that faster, and later we would work on the design for the same thing for the command line. Yeah, but isolated projects is a new feature that's in active development, but again, the parallel with best practices, there are things in Gradle's design that are already sort of friendly to the isolated projects paradigm. And one example is convention plugins. And so that ties back to the all projects callback. You can change that configuration, and instead of root project knowing about everything else and sort of pushing that configuration into the sub-projects, you can extract that build logic into the build logic included build, for instance, and apply it as a plugin. And if that happens in isolation for each specific project, then there is no extra communication, and that means it's just going to work. So if you can restructure your build in convention plugins, that will already be a benefit towards adopting isolated projects in the future. And another thing for reaching out to tasks in other projects, the current pattern that you can use to make that isolated projects friendly is to share the task outputs through configurations in dependency management. So for one project, you would create a configuration to which a task contributes in that project, and when you set up the dependency in the consuming project, you would refer to the project and configuration. And because dependency management is by itself, sort of by nature and by design, friendly to IP, that would work already today. So there is nothing really extra you would need to do. Right. And in terms of, we recognize that even though there are ways you can already restructure your build to make that friendly, we want to make the most obvious use cases as easy as possible. And that's why we started to introduce new APIs to Gradle that make it obviously clear that something is compatible, and also replaces some of the outdated APIs that were not compatible inherently. And that includes things like the isolated project type, which is available as a getter on any project in the build. And for now, it contains just a handful of things, but we'll keep on expanding the API. But the premise is that if you have a reference to the isolated project type, whatever you do with it is going to be compatible, so you are safe. While if you have just the project reference, the majority of things are not compatible. An example of using that, for instance, is reaching out to the project directory of the root project, which is usually the topmost layer of your build, where, for instance, you could have some shared configuration files stored. if I recall correctly, CodeNarc by default expects that, or checkstyle expects that the configuration that you use is sort of shared between all the tasks and lives somewhere there. So that would be the way to reach for that configuration in a safe manner. Gradle is also very known for its callbacks, right, and getting back to the evaluate after kind of thing, so that when you want to snug in some configuration before or after something happens, and for that we have Gradle before project or Gradle all projects API, etc. And as a replacement for all the APIs for the isolated projects, we introduced Gradle Lifecycle. I think it was introduced in Gradle 8.8 maybe around that time. So for quite some releases already. The premise of the API is rather simple. Again, it's a callback you can call during settings script that pushes some configuration onto projects, but because it is designed anew, it is safe to do so. It works through isolating whatever logic you provide to, so that Lambda or the action you provide is isolated, so it cannot capture some of the surrounding state because we know it's unsafe. And when the time comes to apply that to a project, whether the project was reincarnated incrementally or running in parallel, due to isolation, we know that this action is safe to run sort of in a fine-grained fashion against any project when it's actually needed. So that could be a way to, say, migrate from all projects. And another tiny thing that was, I think, added to 8.11 that's going to be released soon is the dependency management overall is compatible with isolated projects, but some older APIs are not necessarily. And for instance, when we were using dependency variant-aware dependency resolution with capabilities, you would often reach out for a project group and version to create the needed string, and the new API that allows you to require a specific feature of another project bypasses the violations and makes it more straightforward and ever more high level in terms of consuming the dependencies that are variant aware. Right. So that was an overview, and now let's freshen up a bit and see something in action, what the isolated projects can bring. Well, as I said, again, it's a very limited scope. It's already there, so feel free to play around with it. But at this stage, do not expect that it would be a quick path to adoption. So enter presentation mode. Right. So let me see. So I have a small build here set up. Let's see. So it's a build with just 3 projects, ABC. Each of those is an application. So it's a Java application, and I also apply a demo plugin to each of those. And the demo plugin is there mainly to demonstrate what actually happens in terms of the configuration time. Because at the moment there is not easier deep insights into the configuration phase, although we're working on this. So this is mainly to illustrate. All it does is it prints the current time, then forces the configuration to wait to simulate long configuration times, and then prints the time again, so we can see. So yeah, and if we go to like a command line and we run the build. So this is the regular case for without isolated projects, right? What would happen today, effectively? And I didn't show it, or I showed it too quickly. So we have configuration cache enabled in the build, but configuration cache does not parallelize the configuration part itself, because it does not introduce the additional constraints for the inter-project communication. So it has to run the configuration phase sequentially. It has to.
So that means if you rerun that build, none of that waiting happens.
True, but first I wanted to show that, so we configure project A first, so that takes 5 seconds, then B, and then C. If I do rerun the build though, we get a cache hit, and so it's instantaneous. So that's good for the cases when we get a cache hit. But even on a cache miss, we don't necessarily want to wait. So if we enable isolate projects, which is currently done by an unsafe flag, which you can do. So once we did that, That's a configuration change. So once we run, oh yeah, we still get a. That's because I was running it before. Let me just make sure we have a different configuration. Right. So now you can see, first on the interactive console, that projects are configured in parallel, shown symmetrically. And if you look at the output, you can see they all started configuring at the same time and then finished. And then the total execution time of the full build is effectively the same as it is for each individual project. That is, of course, with the caveat that this is a synthetic example where like all these projects are independent. So for instance, all of them would have to wait for the root project to be configured because isolated projects preserve project hierarchy. So all the parent projects are configured first. But we also know that especially for builds that grow really large, like these monorepo style, or a build that would contain a number of microservices in that, they are relatively flat, even though you have a number of shared libraries that are reused by every other project. But the leaf nodes are there, and there are plenty, and this is where the parallelism would kick in. Yeah, so this is like running things on the command line. But also, if you run your Gradle sync for the IDE, it's hidden in the presentation mode. By the way, if you didn't know, you can always, like when you run sync and you don't know like why it takes so long, what happens, you can always like open this build tab in IntelliJ, and it would show the actual Gradle output of what's it been doing. Sometimes it's been like downloading dependencies, so that is outside of the Gradle's control. But again, the output, because we run things in parallel, can never be deterministic in that sense. But we also see that like this sync process ran in parallel, and we started configuring C first. But again, we start at like 8 seconds for C, B, and A, and finish in 13. So that means even when you sync your project in IntelliJ, that runs the configuration for all projects at the same time. And this already works for the Java-only projects that you can try. Another thing to note is when you enable isolated projects, that actually implies configuration cache. So that means you don't have to even specify configuration cache in the future. And this is what I meant by configuration cache unlocking benefits going forward. So adopting configuration cache is a prerequisite for isolated projects. So doing that earlier is better for you because it will be easier to get the benefits over here. And I think that's it for that demo. Right.
We'll not set up. Yeah.
So to recap where we are with isolated projects, it's what we call an alpha experiment. So it's really early days. You can still try it out. We already working with early adopters to make sure it has benefits for production projects that that fit the criteria we described. So, but we know there are enthusiasts out there who are trying to adopt it for their own build or adopt for the plugins they author. So you're welcome to as well. At the moment, we focus on the loop of the developer in the IDE, so making sure sync is fast, so that configuration of the projects run in parallel. And right, in terms of if you want to try it now, so what's the way? What are the steps that we would recommend doing so? First of all, take a look at the page we have for isolated projects. You can just Google it. Isolated projects, you will find the page. It gives a short overview of things I described, what the isolated projects entail, how to enable it. But in order to sort of ease your adoption, ease your exposure to that, you can also start small in terms of you don't have to run sync immediately. Start with a help task that effectively only runs configurations in the projects and does not materialize the majority of the tasks that you have in the build that might not be compatible yet. So you run your help task with an isolated projects flag, and you get your initial batch of things to fix. And they will be shown in the same configuration cache report or a similar report that we have with the same interactivity, the same guidance towards where to find the violation, etc. And we'll keep on improving the report to suit the isolated projects use case. And then if you want to try it out for sync, you would have to put it in the properties file, because then there's nothing you directly invoke. It's IntelliJ who reads the build in order to sync it, and then you can observe the benefits that I've shown. And yeah, if you find anything during your experiments, feel free to reach out with us with the feedback. Yeah, that is always welcome.
It's very likely that we'll end up making a more public announcement about asking for feedback in one of the upcoming minor releases. So not 8.11,
yeah,
but one after.
8.11 is already in the pipeline for the release, so that's going to be released really soon. Most likely as the next minor release will be more transparent in terms of how to try out isolated projects, and will probably include even more APIs that feed more use cases, so it's easier to adopt. Right.
Okay, but that's not it. We got one more thing that you may have heard of, which is called declarative Gradle. This started from some of the challenges. I mean, because we use a build language and not a purely declarative format, Gradle has some intrinsic characteristics. One of them is that it's really flexible, extensible, and adaptable to complex requirements, which is definitely something nice. It's also a tool. You'll see it at the end, but we're currently running a developer survey. And interestingly enough, the satisfaction of Gradle increases with the experience. So it means there is quite a learning curve, but otherwise, people are pretty happy once they understand how it works. However, the significant learning curve, that's, yeah, not so great. Compared to other build tools, we often get the comment that not two Gradle projects ever look the same. Which is, yeah, it's something that effectively happens. So based on, these thumbs down, we have no plan of changing the thumbs up, but definitely the thumbs down, we're looking into what can we do. And if you look at an extension of the vision statement that we shared earlier, we have a second section to that. By the way, that still is documentation we intend to publish, like the vision and some of how we think about Gradle. But that second element is about what sets Gradle apart. The first part could be any build tool in a way. And so in that second part, and I'm going to highlight, so it's not too big a deal if you didn't get to read it. The thing is, we're talking about an elegant and extensible declarative language allowing to express builds in a clear and understandable way. Current Gradle, let's be honest, extensibility, that's a good one, right? Declarative, well, I mean, we have DSLs that allow you to put like while loops, structures, internet codes if you want, remote codes, like you can do crazy stuff in a build. I think we had someone arguing the fact that as long as you can probably run Doom in a Gradle build, we have problems. And I don't think anyone has done it, but I mean, if you did, let us know. That would be really cool and fun. But technically, you can, right? So the declarative aspect is a bit meh. And the clear and understandable is definitely the place where it can be a challenge. Because even though we can tell you, oh, please, move build logic to plugins, leave the files as declarative as possible, we all know how software evolves. And if you don't pay attention, and Gradle doesn't have like baked-in linting tools for preventing this kind of thing, so it is a challenge at scale. So based on that, well, we decided to look at a number of key principles. The first one is, can we actually really improve the ease of use for regular software developers, people that are not interested in the build? When your job is to produce features for your application, you do not come into the office saying, nice, I'm going to run builds today. Like, that's not what you do, right? What you do is, I want to add that screen, I want to add that remote integration, things like that. So can we then improve their ease of use for a tool that they have to interact with for different reasons, but they don't necessarily want to master and fully understand? The second one is, can we do that while sustaining that flexibility? because we know we have these build engineers, these advanced use cases where the freedom and the possibility of Gradle are really, really important. And also, one thing that is sometimes lacking is because you can have code, effectively what your IDE can do for you is the same it can do for code. But at the same way, we are in a different domain with more restricted options normally. And so can we do better there? So can we improve the IDE integration and the toolability? Couple disclaimers though, because if isolated project was alpha, this is even more before that. We are currently experimenting. So the things I'm going to talk about next, their current experimentation. They are not designed to be productized that way. We will have to make decisions on some pieces will be productized, others may never see the light of day in an official release. If you want to follow up on declarative Gradle, you will need nightly builds. And when we talk about nightly builds, we talk about the whole chain. So a nightly Gradle version that will have to work with a nightly Android Studio version or IntelliJ version. So there are challenges in trying that out. We actually do demonstrate some of the IDE integration outside of an IDE. We have a tooling API client that is focused on showing how we're thinking and the kind of things we may want to do in the future. And prototypes are changing all the time and are not ready for real projects. I was trying to do a demo. It looks like our pseudo IDE and the latest version actually don't work together as of today. So we have a video at the end, but like I didn't get something that currently runs. So the team is working on that, and it seems some stuff evolved in one project, but not across the board. What are the experiments we're running? Well, one of them is software types. So one of the things we realized is that in Gradle, we have, these top-level blocks, dependencies, repositories, the Java block, and other things like that. And sometimes it's hard when you design that you're building a library, that you're building an application, to relate them and to contextualize those. And so one of the things we're playing with is defining software types, which will be a higher level constraint on what this specific project in your whole build is about. The second part is what would happen if, and again, experiments, right? We added yet another file format, this time being declarative. So that means it's not that you should not write a conditional in there. It's that you actually cannot write a conditional. And what if we play around those lines and then check the kind of integrated tooling we can have? So as an example, that's a current example of a declarative build file for an Android application. It doesn't start with any plugin application. So you do not apply plugins in that file. This is all done in the settings where you've defined my build only knows about these different kind of projects, and one of them is that Android application. Then you see a number of very declarative statements. You assign a value to a property. That's it, nothing else. Then we go to that dependencies block. We are talking about the dependencies of the Android application, nothing else. And so you do not talk about test implementation, Android implementation, variant implementation. All of that is just implementation because there is only one implementation configuration in the context of that block. And then inside that, we have that ability of understanding that under dependencies, you should find this implementation. You can use these project references. You can use these external dependencies declaration. As you can see, for example, the example does not include an integration with version catalogs. That's not yet part of the declarative prototypes. And so effectively, you now have a file, which, by the way, one of the goals we have is that you could copy-paste that in a Kotlin DSL build script, and it would work out of the box. But the opposite is not true, because in the Kotlin DSL, you could have built like conditionals, loops, things like that. So that's the idea. Then in terms of tooling, what are we talking about? So like I said, I can't really do that, unfortunately, live. So we have a client to which you can connect. It's the Gradle API, and then it gives you the ability to see the model that this declarative build file represent. So the left-hand side is all the model that we can communicate to an IDE, interact with, you see that the settings is much richer, but actually if we think about declarative, there is only a small part that is relevant. And then also what we have is we have the relationship between the model elements and where they live in the file, meaning that the model is much richer because we know where that information is, where it has been written, where it's been declared. And so that means we can do things. I mean, you've got this relationship. We can see the way some of the things are overloaded. You've got autocomplete. When you do that in the file, it will appear in the model, so you see it immediately reflected. Because, again, parsing of those files, that's a completely different playlist, whatever. Parsing of those files is much faster, much richer, and things like that. So that's the idea.
So the reason we call it two-way tooling is because it doesn't matter from which side you edit the thing, either your text files or through the UI, the final model would be the same, would be consistent, and that enables much more, much better automation and mutations infrastructure for declarative builds.
So if you've not followed what's next, I mean, the first thing was the first EAP in July 2024. We have a blog post and it guides you into trying it out. The trying it out in the first EAP is really downloading our prototypes and playing with them. You can't really apply that to your own build. That's the goal of the second EAP later this month. Should allow you to experiment with your own builds, and then we will be, of course, continuing to look for feedback from developers and build engineers. And then we have a third EAP by the end of the year. And then normally that should give us an idea of the bits and pieces we want to reuse. For example, one of the conversations we have is, what if that declarative language was actually embedded inside Kotlin build scripts file? And we could have a mode where we tell you, hey, if you're declarative purely, then all of that two-way tooling would work. If you have additional logic, then sorry, we can't run in the declarative mode. And so you lose some of the flexibility, but that then gives the ability to a company, a build engineer, to say, hey, I enforce declarative. If the build files are not declarative, then please fail my build. So these are the kind of experiments we're playing with or will be playing with in the future. And I think that's it.
Yeah.
So thank you a lot for your attention. We do have time for questions, so I'll take that one in a sec. If you have feedback for us, not necessarily about this talk, but more about Gradle Build Tool in general. Like I said, we're currently running a developer survey. You all know Gradle here, so please pass it on to the people that are less proficient with Gradle, because that's the main feedback we're trying to get. But of course, you're also encouraged to submit your answers there as well. And so we had at least one question. Yeah, go ahead. So the question is, with Android, with declarative Gradle, the example I showed was an Android application. Will you have the ability to define your own software type? I mean, using the terminology. And the answer is yes, that's the whole point. And so, for example, we saw a number of configuration options in the Android application, right? Did I just skip the slide? Yeah, sorry. So you see a number of options. You could imagine that my company's application enforces the JDK version, the version code, the compile SDK, and a number of things. And so in your model, these would not be configurable because the file would be limited to the pieces that you want to allow the software engineers to actually change, like adding and removing dependencies, but maybe not adding product flavors or build types in Android. Maybe that's actually closed in your setup. So yeah, that's part of the design. Yeah.
Two things. First of all, I think it was already implied earlier, but also with the coming of the declarative configuration, I guess if you have any complex scripting in your build file, it's probably a good idea to consider porting that to a plugin, right? Also for performance and to get ready for declarative configuration.
Yeah, so the first question is about if you have complex build logic, and you see declarative's direction, then moving that build logic to a plugin looks like a good idea, and the answer is yes, of course. Do that today, like don't wait. And you can have performance improvements. Actually, the biggest performance improvement you'll get is if you go all the way to publishing your plugin and just consuming it as a binary dependency. Yeah, for very large projects, that's visible.
Yeah.
Secondly, if you have the declarative configuration format, I guess it would also suddenly become feasible maybe to have an automated Maven to Gradle conversion tool.
So the second question is, does the declarative format enable the Maven to Gradle conversion? No, I don't think so. Because the problem in the Maven to Gradle conversion, or vice versa, by the way, is actually the implementation of plugins and the possibilities of the tool. And so that's much harder. Like you do customization and advanced things through plugins in ways that are different. And we do not have a goal to, because we have declarative, suddenly we can run a Maven plugin. That's absolutely not a goal. So no, it wouldn't really help there in particular.
Though, as a note, we have the Gradle init plugin, or Gradle init tool has some minor support for migrating Maven projects to Gradle, so you can already try that out today. Also because, you know, migrating to Gradle is easier in a sense because it has all the features that you could use in a Gradle build scripts that would try and mirror the Maven. But as Louis said, it's an open problem overall. Yeah. Any other questions? Yeah.
Okay, so the question is about like the different support and the recommendations for writing plugins and how it ties into, you know, Java versus Kotlin versus Groovy. So first of all, if you write like a real binary plugin with classes and everything, technically you can write that in any JVM language. Like that's your own responsibility. Clojure, JRuby, they're options. However, if you do build scripts and things, then you have to respect what we offer, so either Groovy DSL or Kotlin DSL. There's no plan to abandon the Groovy DSL at this stage. In terms of writing plugins, I think the main recommendation we have is that we ended up finding that like the static languages are actually easier to maintain and evolve in the long term. And some of the surprises we've had in the past is we're trying, you know, to give all these benefits by moving to the provider API, by having stronger constraints on different things, and sometimes we get hit by like really weird stuff. So we had cases where we tried to rename the private field of a property, and then realized that because there was a typo in the private field compared to the getter setter, we had Groovy code out there that was actually reaching out to that private field, which was accidental, right? Like it happened that the developer did the same typo we did ourselves in normally what should be private implementation, but because Groovy, YOLO, access whatever you want, that became a problem. So I guess that's one of the reasons we have a tendency to recommend sticking with Java and Kotlin. I personally, and I'm probably gonna get like things thrown at me, I would say stick with Java because that's where you would get the most compatibility. We've had challenges and conversation with the Kotlin community that because Gradle can only increase the Kotlin language level on a major, they're always complaining that we're lagging behind. Kotlin 2 has been released, but you can't yet use these Kotlin 2 features in your Gradle build. And what it means is that if you end up having a Kotlin plugin that depends on the Kotlin library, and that Kotlin library ends up adopting Kotlin 2.0 language features, you may end up not being able to update that dependency version in your plugin because then it would not run, because in a sense, Gradle is a runtime environment for that. So there are always trade-offs. At the same time, if your company does Groovy code, has Groovy plugins and Groovy DSL build script, then please stick with the language you know, because then you know also all of these quirks and differences in behavior. We probably have time for one more question, and then we will be around the whole week, so you can catch us in the hallways. And if there are no more questions, then thanks a lot for your time and your attention.
Thank you.
All systems are nominal. Initialize Genesis sequence.